we've been talking about how charges interact. We're going to find that the interaction of charges is arguably the most important idea of our entire course. This forms the basis of our second pillar of chemistry, the second of four basic ideas that we're going to see over and over again throughout our course. Before we think about the second pillar of chemistry, let's go back to this picture. Rather than plotting these scenarios on one axis like in the picture, what would a plot of energy versus distance look like for like charges? As the distance changes from 0.5 units to 1 unit to 2 units and so forth, would it form a linear plot or would it be curved? What quadrant or quadrants of the graph would the data be on? Would it have a positive slope or a negative slope? What about a second plot for opposite charges? Would the data be in a different quadrant or quadrants of the graph? Same slope or different slope? Why don't you stop this video and see if you can make two plots before going on? Our second pillar of chemistry states that systems in nature usually seek the lowest energy possible. Nature is lazy. If a chemical system has the choice of being in a higher or lower energy state, it will usually choose the lower energy state. The second part of this pillar is that almost all of chemistry is based on the interaction of charges seeking the lowest energy. Keeping track of where the positive and negative charges are going is the key to understanding chemistry. This idea is the basis for opposite charges attracting and like charges repelling. When you drew the plot of energy versus distance for two like charges, it should look something like this. Notice that the plot is in the upper right-hand quadrant of the graph. Distance between charges is always positive. If the charges are both positive or both negative, then the energy will be a positive value as well. With the distance r in the denominator, as r increases, the energy gets closer to 0. For opposite charges, the distance is still positive, but the energy will be negative. Again, as the distance increases, the energy gets closer to 0. So, how does this relate to our second pillar of chemistry? Think about where like charges go to get to the lowest energy. They increase their separation distance. They repel. How about opposite charges? Remember that we define lower energy as more negative energy. Opposite charges get closer to go to lower energy. They attract. Opposites attracting and likes repelling is simply what they do in order to go to lower energy. This simple idea of opposites attracting and how the potential energy gets lower as they become closer can be applied to the inner workings of atoms, to the physical properties of materials like a melting point, and even in determining which specific atoms on different molecules will bond together during a reaction. Opposites attracting is an extraordinarily simple yet extraordinarily powerful idea.